Cloud.
This meeting is being recorded.
Wow, that was aggressive.
Yes. Well, I guess they want to make sure you know.
So this is the South Sound developer user group. I almost said .NET. I apologize for that. I will take my lashings at another time. But we have Matthew talking about generating tests by describing properties. Let's do this.
All right. Thanks, Carter. Yeah, this is not a .NET talk. This is I'm using TypeScript here. So at least there's some bit of the Microsoft ecosystem going on.
Wait. So you're using TypeScript, but you mentioned Haskell in the...
Yeah, so, okay, the idea is originated out of the Haskell community. And I don't have Haskell code here. I have TypeScript code. And I think by description, I did mention that like the examples will be in TypeScript.
Oh,
and
my bad.
A library called FastCheck, which is derived from the Haskell library Quickcheck. And there are, I think, like 30 adaptations in different languages. I posted in the Slack channel, I posted a link to the code here and my notes, and I've got a bunch of links to other libraries in various languages. The Haskell original Quickcheck library, a whole bunch of others. There's a lot more. There's a .NET one, etc. They all kind of work the same. I think some of them use different terminology for the same ideas, but it seems to roughly be like it's the same idea, which is that rather than coming up with a whole bunch of what I'm going to call scenarios or examples of of specific things you're going to test, you're describing how your thing should behave. And I've got a really simple kind of example that shows this off, that shows off how this works right off the top of the bat. And this is a property of, let's say, date serialization. And I'm pulling in a JavaScript datetime formatter and parser. And what I'm doing here is I'm saying for every date, I'm going to have FastCheck generate a date for me. And I'm going to have it then convert that into Luxon's datetime object. What I expect is that date will equal itself when converted to SQL time, this year, month, day, timestamp format, and back. So this is a common thing to test with this sort of property-based testing terminology. If you have a reversible operation, what are the boundaries of that reversal? And so what I can do here is go yarn dev1a and test. And it failed. And it says failed after one test. Gives me a little bit of information. It goes counterexample plus 10,000 at GMT, presumably. There's a whole bunch of stuff here. The stack trace is unfortunately kind of worthless, but it says got an assertion error, expected this timestamp to deeply equal another timestamp. And when I look at this, the problem is immediately apparent to me in that this is a format that has, 4-year places, and it will fail as soon as you feed it one that is 5 years, or that is a 5-digit year. The year 10,000 will fail this property. And if I wanted to make this pass, I can copy this stuff into my date constructor. And now instead of generating any date, it will say, okay, I'm going to generate a date between these number of milliseconds that correspond to something else. And now it passes. This is the idea behind property-based testing in a nutshell. Is you're making an assertion about how this sort of thing should behave, and then finding the boundaries of what that behavior encompasses. And I've got a few more places where this will come up, but I'm going to move from that into something else. I've got another example that's based off of sorting, and this is let's see if I go, no. I test 1B here, and this is a example of how you might handle sorting. This is an example of sorting a list of integers, and I have, in this particular case here, this is my example or scenario-based testing. Given the list 1, 2, 3, 4, it wants 1, 2, 3, 4. Given the list 4, 3, 2, 1, it wants 1, 2, 3, 4. And my test passes. And it shouldn't, because I don't know if you know how JavaScript sorting works, but when I start putting this in, when I put this into something where it's saying, okay, for an array of integers, basically for every array of integers, I'm going to sort the numbers, and I expect for every item in that list, I expect every item, I expect it to be greater than or equal to the previous item. Do you follow that? It's like, what I'm saying is, in this particular case, it would iterate over the list. 2 should be greater than 1, 3 should, or greater than or equal to, 3 should be greater than or equal to 2, 4 should be greater than or equal to 3, and so on. And now I say this, it'll run the test, and it will tell me that it failed. And what it does is gives me some information about what's going on here. And it says counterexample, -1, -2. One of the ways that, or one of the things that this is finding is it's telling me that my sort function isn't actually sorting my numbers, and it doesn't handle negative numbers well. And I'm using the JavaScript sort function here. Okay, that's interesting. If I can also run it again, there's another way in which this fails, and sometimes, oh, here's one. No, that is also negative. Here we have 2 is coming before. That's interesting. Oh yeah, okay. So the counterexample is a list where it's 2 and 10,000. It's telling me that's also failing. This is one I'm going to iterate on. And what I can do is I can copy this, effectively replay information out. I'm going to put it here as the second argument to assert. And now it will go ahead and run this with the same seed and the same information every time. And I can figure out what's going on here. And the what's really going on is that JavaScript sorts things based on converting them to strings. So if I give this a function and have it return a -b, it will pass. But what this is doing is it's finding examples of what is, given the types that I'm telling it my function takes, and this property of a sorted list, everything should be greater than or equal to the things that came before it. It will go ahead and find examples that fail it. I've got another really quick kind of little dumb example that is kind of derived from something that I actually encountered in the wild once. You can go ahead. I'm going to go ahead and show you add_ts. This is representative code that somebody actually gave me in real life once, where I had given them test cases, like actual examples, and they just had a lookup for what it was supposed to return. And I countered by adding more test cases, and they countered by just adding more actual lookups for what the result was supposed to be. I don't want to necessarily re-implement addition here, but if I cancel this out, my test here, my scenario test is going to pass because I have all the examples that the test is going to run will fail here. It's looking up the input and the output and gives me what I have here. So in some ways this is like, it is you're telling it, I don't think that there are any, I don't think that there is any failing cases for this particular function given what I'm describing. And fast check, quick check, whatever is going to come in and say, oh yeah, I hope you find it. And here in the same case, it's saying, okay, well, I've given you a number here, and I could continue to update this to say like, okay, well, fine, 1, 2 is supposed to equal to 3, and it will continue to tell me, okay, well, fine, now 1 and 3 fail. And as long as it finds something that is going to not you know, as long as it finds something that violates these expectations, it will help you, it will give you the smallest example it can think of for what's going on here. Like I can put in verbose level 2, and it will walk me through all of the particular examples that it tried. The first thing, these are the first numbers that it tried, that failed, and so on and so forth. And it keeps trying smaller and smaller things. So you can see here, we've got some powers of 2 until it finds the first one that passes, and then it backs up until it finds the smallest thing that it can that fails. On the whole, this is a technique that lends itself really well to things that are kind of well described by mathematical properties. I'm going to go really briefly through a bunch of these, and if you have questions, feel free to chime in. And then I'm going to get into some more complex examples afterwards. But these are some things that, like, you can think of them as mathy, but they generally apply to some basic data types that we have. Item potency, for example, is something that kind of comes up in this, like how you might describe the behavior of functions. And let's see, I can cancel out of that and go on to, all these are passing here, but item potency, for example, is saying if I call a function with a value and then call that function on the result of the value, it should be the same. And this is something that if I'm filtering a collection of numbers, for example, this one is saying if I filter for any collection of numbers, I filter by 2, that should equal it when it's been filtered twice. Or sorting is another one where that should, I can sort a thing as many times as I want, and the result should be the same. Trimming white space off the end of a string, adding an item to a set. These are all things that are item potent. Repeated calls should not change the outcome of it. Another property that lends itself really well to this technique is something called involution. I believe that's what it's called, where in this particular case, it's sort of the opposite of item potency, where calling the function again has the reverse effect, or it returns the original result. Reversing an array is an example of that. The there and back again example of formatting and parsing. And this is the way that ISO string formatting works. This holds true for ISO string formatting in a way that it doesn't for SQL time formatting. And JSON serialization and deserialization. And here I had to get into, I'm giving it like an object and the kind of values that go into the individual leaves on the trees that it generates. But for the float type, I had to specifically tell it, don't give me infinity, don't give me nan. And because JavaScript has positive and negative 0 and they do not equal each other, and that sign of the 0 gets lost in the serialization, I also had to remove the sign in generating this float value. If I were to remove these, it would fail. And I can, oh wait, I have to call. If I run this enough, well, okay, it was failing before. Oh, here we go. So it's saying is, okay, number negative infinity is a counterexample that fails this particular there and back again problem, because that does not get serialized as a part of the the way that the JSON serialization and negative serialization works. And similar to the thing that I showed you earlier, it's going through a particular path to find that this is the smallest value that triggered that particular failure. Let's see, I'm going to make this pass again. What was another one? Commutative is the order of the arguments doesn't matter. And this is one of the things that is commonly described, like a property of addition is it doesn't matter which number comes first, the result's going to be the same. Addition has that, multiplication has that, set intersection is a place that has that. Hash map merging does not, because if you have conflicted keys with different values, then one of them has to win, and typically the order of the arguments does matter there. Distributive is a thing that describes where the order of operations doesn't matter. In this particular case, I'm saying that the function on a plus b is equal to the function on a plus the function on b. And so string capitalization might be a good example of that. I'm generating two strings here, adding them together and calling that on uppercase and saying I want that to be equal to uppercase on the first string and two uppercase added to two uppercase on the second string. There aren't very many examples of that particular one out there in the wild, but it is something to kind of think about with this stuff. Associativity is another property where what this describes as grouping doesn't matter. A plus the group of B plus C is equal to the group of A plus B plus C. This is something that generally applies to things that are concatenative in nature. Addition is one. Taking like the minimum and maximum of numbers is another. Concatenating strings and hash map merging actually is associative in this particular way, as long as the order is the same. You have identity and zeroing operations. And so this is like, you've got a special argument where it makes the operation return the other argument or makes it return the special argument. For identity operations, that might look like n plus 0. For any float that is finite, I expect that plus 0 to equal itself. N times 1. The same thing. I would expect for any finite float, I would expect that to equal the number that came in. Any number divided by 1, concatenating an empty string on something, unioning a set with an empty set, taking a difference of sets with an empty set, merging an object or a hash map with an empty hash map. Those all have identity properties. Whereas zeroing is kind of the opposite of that. Any number times 0 should be 0. Intersecting a set with an empty set, removing items from an empty set should always be zeroing. The final one that I have examples for here, injective operations. Okay, this is if a function applied to x equals z, and the same function applied to y also equals z. Therefore, x and y are equivalent. This is a property that comes up a lot in cryptography, what I have here is an example of generating a tuple of strings where they're not equivalent. And I'm saying if I SHA-2 12 those together, they should not be equal. And I could run this until the cows come home, and hopefully I won't ever have a hash collision. Let's see here. I don't really have any examples of these because they're all kind of trivial, but bijectivity is another property that lends itself well to this technique, where, for example, all inputs map to exactly one output and vice versa, so therefore it's reversible. Array reverse is an example of that. Pushing or popping onto a stack or a list-like structure, same with shift and unshift. And then things that do serialization or deserialization have this property. I've used this for a lot more complicated things, though. These these basic things are really good for functions that need to get a lot of things right and have a wide variety in input. If you're doing math, if you're doing like a lot of special math, or if you're doing a lot of things that deal with cryptography, there are a lot of good tools in those particular properties to pull out. But I've used this for a lot more complicated things, things that involve state, things that might be sequential or result in race conditions, things with very complex inputs or outputs, where it does this technique becomes difficult to apply and difficult to work with is things that have very opaque state or non-deterministic side effects. Those are not things that lend themselves well to property-based testing. But one of the things that I think touches upon, so I guess like, generally, unless you're testing specifically equivalent implementations, you don't want to have a parallel implementation of something. And so you have to start thinking about, what is it that this thing that I'm doing actually does under the hood? And what are the results like? What do the results look like more in the abstract? So squaring numbers results in a positive number. Again, I'm taking all my finite floats here, I'm multiplying them together, and I'm expecting the sign of that basically to be 1 or 0. Because if it's 0, this math sign is a JavaScript function that returns -1, -0, 0, or 1. And for whatever reason, -0 is greater than 0, even though it's not equal to 0. Don't get me started on JavaScript's number system. But this is the sort of thing that the technique encourages you to think about. Another one is triangle inequality. I had a fun one here when I was coming up with this. The basic idea of triangle inequality is for any triangle, if you take the two shorter sides and add them together, the lengths of them together, the result of that should be greater than the length of the third side. And rather than getting into the weeds with actually like generating an angle and calculating out the length of the third side, I just went with the right triangle for this. So I'm saying, okay, the square root of a squared plus b squared should be less than the values of a plus b. And if I save this, it will tell me that this is not true. And it's like, oh, that's interesting. Okay, so my counterexample is 0. Okay, well, I guess I need to make sure that I have a positive number. So I'm going to filter the result of this where n is greater than 0. And then it's going to come back and it's telling me that it's failing again. And I look at the result here, and I'm dealing with two very small numbers, e -158 and e -324. And I look at that and go, I'm never going to deal with this in real life. Where am I? But what this has illustrated to me is that while the property may hold true in the abstract, because my implementation involves floating point numbers, I am dependent upon floating point precision for this to hold correct. And, that might be a really valuable thing for you to know in the application of your function. I don't know. A lot of the stuff that I do tends to result around edge cases and correctness. And this technique has helped me find weird bugs about assumptions that I've made about things like floating point math, where maybe that case will never come up in real life, but if it does, I'm never going to know, and it's going to be a horrible bug. So it's in that particular case, like whatever the consequences would have been, this is something that helps me avoid that, and it helps me reason about what are the boundaries for my inputs. And so I can reasonably say that for a range of about 16 exponents, if I change this to e -7, for a range of about 16 exponents, I can expect this to hold true. If I make this 7, then I make this 9, it will still pass. I feel like it is a thing that if the results actually matter and have consequences for getting it wrong, it's a valuable thing to know. What are the boundaries of my system? And in that particular case, I just would like to kind of illustrate maybe the 3 types of bugs that I've seen in the wild. And one is what most people think of a bug. It doesn't do what it's supposed to do. And everybody knows those bugs. We've all seen and had them. And then there's the occasional, what I would consider a design bug, where it's doing what it's supposed to do, but what it's supposed to do is wrong. And that was just, nobody really thought through requirements gathering. And this is a technique that can kind of help you find a lot of those. The third type of bug that I have, and I like, this can also help you find this sometimes. We don't like what it's doing, but we're not sure what it's supposed to be doing either. And if your input has, if whatever it is that you're testing has weird edge cases, this can help you find that sort of stuff as well. Now I was going to go into some examples and whatnot based off of some things that I've actually worked on this in the wild in real life. And these are all simplified things, but the one particular place where this can shine is testing equivalent or reference implementations of something. If you are trying to come up with a novel way to sort something, then this can help you validate that the behavior across parallel implementations of something are equivalent. For one project I had, we needed the client-side sorting algorithm to behave the same way as the JVM-based sorting algorithm to behave the same way as a SQL-based sorting algorithm. And those all act differently out of the box. The JavaScript, even the string sorting stuff, behaves differently from the JVM string sorter, behaves differently from PostgreSQL string sorter. And I had to effectively roll my own sorting algorithm in Clojure for both the JVM and Clojure script for JavaScript and validate that it was equivalent to what was coming out of the database from SQL. And this helped me do it. The other thing that I've done for this with what I would consider to be an equivalent implementation is query engines, where I had generated a lot of data for the database and some variables to represent a particular query that was being done. In my test code, had a way to have a parallel implementation of the query in code, and then it would validate that the thing that generated all of my SQL for me was produce the same result. Does the results from that query equal the same as what the code is doing? In this particular case, it helped me catch, because it was dealing with HIPAA-protected medical data, and because it was doing statistical aggregation. If there was a bug in the way that the particular stats were being calculated, nobody ever would have found it. Nobody would ever have even known that there was a problem, because they're just looking at, some average or some percentile kind of thing that maybe looked right, maybe didn't, but there was no way for them to know. And this helped me catch a lot of bugs in that thing that I never would have thought of from going to look at on a scenario-based testing basis. I have an example here of this, just like, this is passing, it's super simple, but for any string that matches an alphanumeric with spaces string, then I would expect the uppercase version of it to sort to produce an uppercase sort to produce the same results as a lowercase sort. It's the sort of thing that you might have out of an equivalent thing. Where we start getting into the real fun, though, is sequential operations and state machine behaviors. This is the state machine thing in particular helped me catch one of those. We don't like what it's doing, but we're not sure what it's supposed to be doing either. When I was working in a particular case in healthcare that I like, out of everything I've done in my career, this is probably the thing that I'm the most proud of, was using this technique in a state-based, in a state machine kind of model-based approach to understand behaviors that could have gone massively wrong. And here's, I think, the first time when I'm going to actually start walking through some of the code. I have a very simple, and actually hacking on it a little bit too. I have a very simple state machine emulating a turnstile. The idea behind it is I put in a coin, and it is going to, it's looking for a coin of a certain size or more. And if that coin is inserted, then it's going to unlock it. And then I have a push transition. If the turnstile is unlocked, then go ahead and lock it and return that it was unlocked. And all this code is specific to FastCheck's implementation of this. When I did this before, I was working in Clojure, and the Clojure test check implementation was radically different because Clojure is not a class-based language. But I am telling it that I have a simplified model of my state machine, how much I've spent, and that's not really relevant yet. And I have two commands. I have an insert command where it keeps track of the value that's being inserted. Check is basically, can I run this command right now? And run is the thing that actually runs that command across my turnstile by inserting the coin. It's incrementing its internal state and then validating that it behaved the way that we thought it should. And then I have a push command. Okay, was the turnstile locked? We're going to call the push and validate that this is happening. And right now, it's behaving just fine. Then we go through and I'm giving it some commands. I'm giving it a natural number that is, by natural, it means a number one, an integer one or greater that is finite. And for any of those coins, what it's saying is if the coin is greater than, what is TS file? Oh, so the natural number is, in this particular case, is the amount that it wants in order to let you through the turnstile, how much the turnstile costs. And then the command here is generate another natural number and make a new insert coin command with that number. And in this particular case, what it will do is it will go through and exercise this. And this is passing because the code is currently passing. But the way that it works right now, it doesn't have any concept of a balance. If I were to put in two smaller coins that added up to the same amount, then it wouldn't do that. And so I wanted to, very simply, start going through the process of modifying my assertion about this particular state machine to add a balance. So I'm going to add a new property, and that, I'm keeping the commands the same, but I'm just going to have balance number, and we'll go with 0 insert coin. And this particular play time, we're going to go plus equals size. And then rather than size here, we're going to go with balance. And I'm going to modify this a little bit so that, let's see here. Okay, wants amount. In this particular case, it should be spent is equal to this value. Okay, so I'm going to say that m spent greater than, no, M spent is greater than or equal to once amount. And then when I push, I'm going to say M spent equals 0. This should probably fail off the top because I didn't clear the balance or subtract the amount when it happened. And what it's telling me is that it is starting, it has a value of 0, and it inserted 0, and it failed. This didn't happen before. I guess 0 is included in the natural number. To equal, and spent is greater than or equal to, wait, yeah, or walked. This balance is greater than or equal to this once amount. 0 plus 0, so 0 is greater than or equal to 0. It's probably one of the JavaScript negative number things. I'm going to modify this a little bit to say that it should only return numbers greater than 1. JavaScript kind of bugs me sometimes with these, with the function, the snappy function syntax, but I don't know. Okay, let's see here. So 1, insert 1, and what's going on here? Expect rlocked to equal. The money that we have spent. Did I construct a model here? Maybe that's it. I'm going to turn on the verbosity as well. Okay, maybe that's not super helpful. What I can do, however, is copy this in, and it will, I mean, it doesn't, now it will run the exact same check every time. Wait.
Was your logic for locked backwards, Matt?
I think so. I was a little bit hesitant on the live coding here. So, okay. This balance is greater than or, oh, it's locked. Yes.
Never be hesitant on the live coding. The live coding is
yeah, okay, there we go. So 1, insert, insert 470,128, 470,120,484, push, insert that. That's interesting. I wonder what happened there. rlock to equal, did we, I think it might have encountered an integer overflow. Let's see here. I'm gonna pop open a new terminal real quick. No? Huh, okay. Well, it's interesting that those really large numbers are the smallest examples I could necessarily find. If I wanted to turn this verbosity back on, you would tell me here, insert 2. Oh, no, 1 push, insert 2. Okay, so here, oh right, so I haven't finished my model yet. So here in my test, I have reset the amount that I've spent. What I haven't done yet was, and actually it's not even that, it's going to be RM spent minus equals our wants amount. And this is still going to fail, but what I didn't do here is when we push it, we're going to have this balance minus or equal to this wants amount. And in this particular case, it's failing. It's saying, okay, I insert 1. I have a wants amount of 1. I insert 1. And, oh, okay. My test here is wrong, where I'm saying I need to have No, once amount. I'm not checking the balance. This balance minus or equal once amount. So I'm inserting one coin. Expected true to deeply equal false here, or locked. So that is back to this. Balance or is greater than or equal to. What the heck? Nope, same problem. To equal spent is greater than or equal to 1 cent. Well, here I can start putting in let's see here. Man, oh, there we go. Right. I did not actually construct the model. This is, okay. Now it's getting me down to 1, insert 2, and I'm going to hide that. And let's see here. This balance is, no, okay. Lock is, this balance is less than once amount. Okay. 1 insert, once 1, it inserts 1. You know what? Okay.
I think you got a thing on line 20 as well. You want this dot locked. You're just giving it the opposite of locked and not checking whether it is locked.
Yeah. This this is failing in the push command test here. So it's failing here. Wait a minute. No, it's failing here. So spent R once amount. One insert 1 where so it's going all the way back down.
You have locked should be equal to be whether it's
wait a
is
minute.
greater, but that should be the unlocked.
Backwards. I have this backwards just the same. Okay. There we go. Okay. So now this is working. If I uncomment this bit about the balance, it will tell me that it can fail this by having a cost of 1, pushing and then inserting 1. Oh, that's interesting. Oh, so that's interesting. What it was doing is I'm going to modify this a little bit, actually. If not.
Sorry, can you explain that failure in a little more detail? Like what would cause it? You want 1, you push, and then you're inserting 1. How is that failing?
I was pushing, and it was what happened. So okay, let me explain what's going on here. So this is my command list: is push, and then insert 1. What it was doing was, regardless of if it was locked or not, it was subtracting the once amount from the balance. So it was locked.
Oh, I see. Okay.
And it's going ahead and subtracting from our balance. Return true. Okay. And now we're back here to this 1 push insert 1 expected. Wait. So the push. So this isn't even about the push. It's failing on insert 1. Push this balance if we're locked. Otherwise, remove something from our balance. Got quite the path there. spent is equal to this value. And it's regenerating the model every time. It's regenerating the turnstile every time. And let's see, just try something real quick here. Oh, I don't, oh. No? My keyboard just died. Did it? No. It's not responding to the terminal. There we go. Okay, same problem. 2, push, insert 2, and push, so it should be returning false, inserting 2, incrementing the balance, and then saying this balance walked is less than once amount. I believe that should be correct. Otherwise, balance is less than. Go ahead and subtract out. Actually, you know what I could do? I can probably just simplify this. And say, okay, if balance is greater than, is less than this once amount, this balance is less than once amount, then we're walked. And at that point, I don't even need the walked state. I can hide that. Was walked is now going to be, is the balance less than the once amount? And I don't need to check that. And oh, okay. This was a problem here where it was continuing to decrement my spend. If was walked. Okay, now it's saying 1, insert 1, expected undefined to deeply equal false. That is where? That is here, our walk. Oh. Insert coin. I don't necessarily need to make an assumption here, make an assertion here. I can just give it a sort of physics test here. Expect okay, now it's saying push and insert 1. Well, okay, I'm not going to make an assertion here because I don't think I actually need one. What it's saying is, let's say if I'm going to introduce a bug. Or at least I think I'm going to introduce a bug. No? Okay, maybe I do need an assertion here. Expect our balance to equal okay. I don't want to get too far off in the weeds on this because the next one is similarly fun. 1, insert 1, expected 1 to deeply insert 2. So somehow or another, this value plus previous value is inserting 1. Somehow or another, I have spent plus value. balance size. I'm going to probably wrap this up soon. Yeah, I'm going to go ahead and say that I'm going to drop this because I don't want to get into the weeds on live coding around a technicality. Where I think that I can show that there's some value here is that what it is doing is, you know, if I were to tell this that I have nothing, it can tell me that, you know, this is the minimum number of commands that it can take to fail my test. Or if I'm going to, let's say, double my my coin size, well, here. If I didn't actually decrement this, no, okay, it's hide that one. Okay, if was locked. Wait, no, if not was locked. That was my problem. I have these things backwards. Is this working now? This is not working. Okay. The general idea about this, though, is you can give it a list of these commands. The race condition example that I have next is a very similar idea. But you go to a list of these commands, and it will apply them in an arbitrary order with all sorts of values. And it will tell you the shortest path that it can find towards failing the thing. I could go over and reset this and try something else real quick, but I want to keep this short. And the race condition one is, I think, similarly, maybe a little bit more enticing. This one I had commented out to start with because it fails off the top. And didn't want that to cloud all the other ones. But what I have here is a very simple model of a wallet with an asynchronous spending, an asynchronous transacting operation, where I give it a starting balance, and I have basically a sort of thing where I'm saying, give me a scheduler. Give me an array of these records where I have an amount, I have a time after which to start the transaction, I have a time that the transaction is going to take, and I have a Boolean representing whether that transaction will succeed or not. Go ahead and construct the wallet. This is managing JavaScript promises. None of that is very exciting. I'm telling it to go ahead and schedule a bunch of these functions after a particular time and wait for all those to resolve, wait for all the promises, and when it comes back, then what I'm expecting out of my wallet is that none of the balances, it's checking the balance every millisecond here, and it should take no more than about, I think, 20 milliseconds? No more than about 50 milliseconds. So it's going to check the balance 55 times over the course of 55 milliseconds. And the balance should always be positive. And what's happening here is we're depositing 6, we're spending -1, or we're spending 1, and then we're spending another 6. And after that, we have the balance fails with -1 after the 7th millisecond. And I mean, I'm using this as an example. It's based off of a fairly simple problem in the fintech world. A lot of times you can't actually have transactions that work this way. And if it's imperative to you that your wallet never have a negative balance, then what this might point to is that you need a new concept in your model. In this particular case, I'm going to give it a reserved value. And I'm going to say, okay, we're checking the balance. If we can't spend the money right now, then return false. Set the timeout. So if the transaction is going to succeed, and then I'm going to add a new thing, which is, wait, okay. I'm going to, before that, I'm going to say reserved plus equals amount is balance minus equals amount. And in our timeout function, then it's going to be this reserved is minus equals amount. Wait, no. And I want the opposite of this. And if it fails, then either way, if actually, let's see here. If we don't succeed, then we want balance plus equals amount. And I believe this is this notion, adding in this notion to our model of having a reserve balance should do it, but apparently not. We have the same transactions here. This reserve number, no. Okay. The same transaction state here. We are adding 6, subtracting 1, 6, and it's going straight to -6 this time. Wait a minute. If this balance plus amount is less than 0, return false. Plus amount. Oh, I have these backwards. This reserve plus amount, and this is going to be okay. And now it's passing, and it's telling me that it can't find any situations where it's going to have a negative balance. Getting my directions right here was kind of crucial. In this particular case, I have it running the test 200 times. If I wanted to crank that up and have it run, say, 1,000 times, I can do that. It'll sit here and churn on it a couple times. And let's see here. We have 1, -1, and 1. What happened there? Where our balance was array 55, function to satisfy all positive. So that failed. We did hit a balance of -1 here somewhere. Interesting. Resolve with true. JavaScript is single-threaded, so I shouldn't be hitting any if not succeed, we're returning the amount to our balance. So this is we're adding 1, and it's false, and it's going, oh, it's not going to this balance. Okay, I know what's going on here. If this amount is less than 0. Maybe, maybe not. We have a single one now. If amount less than 0. No. +1, it's not going to succeed. -1, it's not going to succeed. Resolve with value true. We're hit, and somehow it's getting through. Mm. Resolve the value true. So I'm looking at this. Man, okay. So it's interesting here. Well, this is always the danger to live coding. You think you know how to do it, and then you're wrong. If not succeed. You know what I think I need? I think I need a delay greater than or equal to 0. I think that might be what's causing the problem here. Oh wait, no, it doesn't take. No, okay. The JavaScript scheduler is not all that good. Although now I might have parked it. Oh, great. Okay. I think it just caused it to die. Regardless, you know, I think this also this illustrates another situation with the test harness, where rather than having to construct an elaborate scenario around this is the sequence of things that needs to happen in order to produce a particular result, and having lots of those and have to think about what each of those are going to look like and come up with them and specify a lot of data. What this can tell me, what this can help me do is if I can come up with a general thing that I want to make sure doesn't happen. If I can come up with an assertion like a bad thing shouldn't happen, this can help me find places where it does. I don't want to sit and spin on this too much more, but like in that kind of failure mode, what I had here was an example. It's called the where I'm taking the test harness and using it as a solver of sorts. I don't know if you're familiar with the water pouring problem. There is a link to this in the README, where this was featured in Die Hard 3, but the general idea behind the water pouring puzzle is, let's see here. You know, you've got 3 jugs and you need to get a certain amount in some of these and some not. And I have a abstracted version of this water pouring puzzle, and I'm telling it this is based off of the state machine model, where it's a one command, or I make some assertions about the physics of the jugs, and then what I'm telling it here, I have 3 jugs. The starting amount is 8. The capacity of it is 8. Starting amount 0, 5, 0, 3, and then I want it to be at 4, 4, and 0. And what I'm telling it is that the jugs amounts should never actually hit what it wants it to be. And so if I run this, let's see, oh, I have to actually uncomment this. Then it will go, okay, let's see how we can get it, how we can go from having 850 into 440. And this is basically the same solution that will come up, I think, on Wikipedia. Pour from the first jug to the large jug to the middle jug, and now you have 350. Pour from the middle jug to the small jug, now you have 323. Pour from the small jug to the large jug, 620, and so on and so forth. And I've basically turned this into a solver as well. it took a lot of different paths to get there. I can increase my verbosity on that, and it will actually show me what those are. All the different iterations that it tried in order to get there, a lot of different things where, you know, sometimes it's putting in 100 commands in order to go through this effectively state-based problem. But
sorry, are you using this, the failure is actually the success, like you're kind of
yes,
inverting this because it's the test system is designed to search for failures and you actually have a problem that you're searching for solutions. Okay.
right.
Wow.
what I'm telling it is there's no way for you to solve this waterboarding problem. Prove me wrong. And not only is it proving me wrong, but it's showing me the simplest solution that it comes up with. Despite that, it iterates through a bunch of other completely wild solutions and rules them out based on, like, it finds the path that it needs to take to get to that smallest set. You know, people have also used this this technique to do UI fuzzing. If I've done a lot of UI programming in my career, I try to model my user interfaces as state machines, but you can also hook things up like this to either to those state machines or to just like Selenium and go click on random things and then assert that anything that is clickable doesn't put the page into a bad state. You can the fast check documentation has an illustration on how to hook this up for fuzzing, and I also, in the medical data statistical aggregation thing that I had used this for SQL stuff on, we also needed to demonstrate the system to people, but we couldn't use it with production data. And so I use this as a way, I also use this as a way to generate a lot of different sample data for the salespeople to use in helping sell the product and to demonstrate the product to people. You know, I had was planning to do a final part on generating values, and then I realized, you know what, it's tedious, so I want to try to keep the talk short, and it also just varies a lot from language to language and library to library. The basic idea behind all these particular things, like let's see here, like having the natural numbers and filtering off of that, and having things like where was it, the record, I think maybe it was here, no, was it here? I'm generating a record, and every you know, I'm passing it a JavaScript object, but every value in that JavaScript object is another generator. And even like, it's even to the point where I can't fake this out with a regular Boolean here. It has to be another generator. If I wanted it to be a constant, then I have to wrap it in a constant type. And the basic idea behind this is that I'm not giving it data. I'm giving it a tree of generators that it knows how to iterate over. And this is how it can do the shrinking thing, where it finds the smallest failure out of once it finds one failure. It knows how to go through each individual leaf in that tree and make it smaller. In the case of like a list, it can reduce the number of elements. In the case of a number, it can make the number smaller, and so on and so forth.
So earlier you were calling map on a generator, and that's not regular map. That's like a different thing, right?
Yeah, like I've got, where was it? Not the state machine, it was the race condition one here. So I've got, you know, filter and map are the closures test check has this as well, and so does, you know, so do all of them. But basically, it's a way of saying, okay, give me a natural number and then refine it further. Filter is a way to tell the generator to reject certain values, and it remembers that as it generates new values. And then map is basically a way to transform them. I think I had that here where I'm saying generate a natural number, filter out the numbers less, keep the numbers greater than or equal to 1, and then generate a new insert coin command here. In this particular case, because push command takes no variables, it's a constant, but that's still a generator, and it will give me a new instance of that command every time.
So in theory, it's very similar to map and filter because you're operating on a sequence of values, but it's an analogy. It's not literally the same thing. Yeah.
Right. I mean, I would take map more in the sort of like Haskell option sense rather than the like closure functional, the closure list operation sense, where you know, like in a language like Haskell, you would map over an option basically to say if this value is a you know, has a value. If it's a right rather than a left, then go ahead and do the operation on the value. But if it's a left, then don't. Map in this particular case, it's a similar idea where it's like take the value and transform it. You know, well, let's see. I can pull up like test checks documentation real quick. I don't think it matters too much, but oh, come on.
Sorry, I know you're trying to make it through this talk without talking about monads.
Oh, yeah, no. Let's see here. Oh, come on. No, really? Here we go. You know, as I said, these tend to be different from library to, no, not these docs. I want good docs over here. Both, I forget what Clojure calls the particular generator things. I think it just calls them generators. Haskell and this library call them arbitraries, and you know, you can have a lot of ways to specify primitive types and composite types and build up from there. You've got your you've got stuff like you know, there are tools in a lot of these libraries to generate things like recursive structures. You've got let's see, this has where's option? You know, if you need like a, maybe it's a value, maybe it's not. Here we go, combiners. Option is the kind of like standard way of doing it for a lot of those. And it's like, okay, maybe this is going to generate a number, maybe it's not. But you're wrapping another generator in that particular regard. One is one that can help you with union types or a particular path. When I was generating data for the medical statistics system, I had to use one of a lot to kind of mimic the properties of the actual data that I was trying to emulate. But these are ways to basically just take your primitives and refine them into something that the generator can work with. So, yeah, I'm sorry that I wasn't more prepared with the examples. I'm happy to answer questions people have. As I said, this is a technique that I've used with great success and has led to some of the proudest things I've done in my career. I like it because it really forces me to think about what I'm doing and what the boundaries of the system that I have are. And it helps me get out of needing to populate a lot of individual scenarios and, you know, it encourages me more to think about, well, okay, how do I know if this is really working?
Yeah, finding the edges, I think, is fantastic. But I do like what Phil pointed out, like that you had a problem and were seeking a solution and using it to find that. That's cool.
Yeah, it's you know, I've used it as a very collaborative tool for the things that I've used it on, and also when I have it find an edge case like that, you know, it like I can take the actual data that it's giving me for the inputs and then copy and paste that into some actual scenario test code as well. That way I've got like a list of all the edge cases that it's found, and I can validate that those never happen again. You know, if you're one of these people who are like, well, CI must be predictable, and every time that the CI runs, then it, you know, it should not produce intermittent failures, this might not be the right tool for you because it's going to run different tests every time. And when you have a really large system, you might find different edge cases every time. At the same time, you know, if it's important for you to find those edge cases, then it might be worth it.
Have you looked into the idea of splitting out the generative test from the regular suite? Like, if you, sorry?
Oh, yes. And, you know, I've done that on certain projects too.
Because it seems like there's, you know, if you introduce a change and it just randomly happens that your generative testing on that push finds an unrelated bug, like it's going to be really frustrating if that like prevents you from deploying or whatever, right? So how does that work in practice where you like, what's the dynamics that it changes around that if you kind of decouple that from like, is this a good build, yes or no?
The way that I have had this work in the past is for that particular case, you know, the scenario tests are what's it past CI, and a failure from the generative test is something that does not like trigger a build failed. It's rather like there was a warning, and then in that particular case, it's like, oh, okay, this produced a novel failure for us. In all these cases, though, these are things that you know, they like, yes, CI runs it because they should be run often. And they, particularly for large trees of data, 100 runs, 1,000 runs aren't going to find all of the particular cases every time. And so it just needs to be run often. In these systems, I would sometimes just turn it on to like for, you know, I would turn it on to run 10,000 runs while I went to lunch, and you know, just like have it come back. You know, I'd come back and say like, okay, well, I didn't find anything this time. Cool.
I don't know if this is really feasible. I don't know how I would build it, but what really sounds awesome in my mind is like your generative test finds a failure on your branch that you just pushed, and it records the path it took to get there, and then it goes to the main branch and says, is this, given this seed, can I reproduce this on main? Right? And if you can, then it's like, hey, I found a new thing, and I'm going to put it on your backlog or whatever, right? It's not gonna block. But if it can't reproduce the problem elsewhere, then it's like, actually, you kind of screwed this up, and you shouldn't merge this, right? Like,
that's interesting. Yeah, I mean,
you're looking for the test blame feature. That's next level.
Right. Well, I mean, I haven't really even thought about it that way, from the perspective of like, okay, you know, I have a novel failure on my my topic branch, and is that same situation causing a failure on main? That's a good question. You know,
recording that and then, oh, that would be cool.
I mean, I work at a CI company, and I've never heard of anything like this before, or even like the tool, the foundation you would need to even like accomplish this.
So I think what Phil is saying is we need to work on his annual bonus by figuring out how to implement this so he can build it at his company, and they can be groundbreaking.
Because so we at work, we don't use property testing at all, but we do use generators a lot. And so we have a system that says, hey, just give me some bogus made up data. But we don't have any of the system around like you found a problem, like try to narrow it and like be smart about your generators. Use these properties to try to none of that. And I found that it does result in a lot of flaky tests. And I think if we were fully using the power of property testing, then those flaky tests would be justified. But in our case, it kind of feels like we're getting a lot of like non-determinism and not getting a lot back from it the same way we would if we really leaned in. So I feel like we got to go all in or back off a little. But yeah, I don't know. But being able to tell the difference between a legitimate problem from this change versus a latent problem would make that a lot less of a concern, you know?
Yeah. I mean, I think, as I said, anything that any sort of test that is highly impure, where it's dependent on outside context, this is maybe not like the best fit for. You're talking about like flaky tests or whatnot, and the sort of canonical example I have is the first place I worked at in my career was a consultancy, and we had a flapping test. It would fail when it was run between 4 and 5 p.m. Pacific time during daylight savings time. Only during daylight savings time, and only when it was run on only in Pacific time. If your computer was set to Mountain Time, same time, whatever, it wouldn't fail. And to me, that's sort of like canonical example of a flaky test, but it's highly dependent upon external state, things outside the control of the test, and that sort of thing. Like, having good solid tests, I think, just means reducing a lot of that stuff.
Well, we took a different approach on that in my system. We made the clock we put the clock in control of the test suite. So the code base cannot access the clock other than the one that we provide it. And so that's been a lot of fun, actually, because it's an external source of input. Like you don't want to have no control over that in your test. Right. Like that's no good.
Well, that's a common .NET thing, and actually I think it's a .NET 6 or .NET 8, whatever, they fixed that, and they allow you to replace that output. Whereas, for 10, 15 years, I've been writing my own replacement for that and dropping it in. They're small and simple, right? But that's a very recreatable thing. Is time zone within daylight savings or with outside daylight savings, and then there's freaking Arizona that you got to take them all into account.
I have to use India, the Noida time zone for some of my work, and that's in a 30-minute one. That was fun.
That's good times right there. I love it when somebody puts something on the web and they're like, "Oh, time zone doesn't matter." And I was like,
Mm-hmm. Time zones are a thing that I could probably give a lightning talk about sometime. Yeah.
I really think we should all run on GMT, and then everybody just adjusts their schedule based on what they want. But if you set a meeting at a time, it's at the same time for everybody. It won't work, but ideally, I think it's great.
I think you could I adopt like relative time for all my on my chat stuff. Like I'll never say a time unless it's a different day. Like it's always going to be, did that happen 2 hours ago or did that happen like 3 hours from now? But it just clears up so many problems.
Fair.
For these assertions, changing the subject, for these assertions, would it work as well for doing stuff that is inequalities? Like if you want to say you do a union of two sets, then you know that the count of the resulting set is going to be at least as big as the biggest of the two sets.
Right.
But it may be as big as the sum of the size of the two sets.
Right. So I guess, you could say there, a property of that operation would be the result will be between the largest set and the sum of the two. Another one that would come to mind for me is that for any member of either set, it should be in the result.
Right.
I mean, go ahead.
Yeah, some things like that also come to my mind when I hear the idea of properties.
Yeah, I mean, for me, this technique, I think, requires you to just back up a little bit more and try to look at the problem of, is this working or not from a, here's my input, here's my output perspective, but rather like trying to think about, okay, how do I know if this actually works? How do I know if this works without examples? How can I describe to somebody in a broader sense what a condition of success is?
Yeah. Well, and I like the idea that you can it can be easier than generating all of the test sets, but it can find and think, randomly come up with stuff you hadn't thought to include, and if you hadn't done an exhaustive, without having to go through an exhaustive test of every single input.
What addition is, I think, a common thing that people describe when explaining this, and so like it doesn't matter what order the numbers are in is a property of addition. But then another one you could say is like for a subtype of that, for any two positive numbers, the result will be greater than either of them. For any two negative numbers, the result will be less. And for a positive and a negative number, the result will be somewhere in between. It doesn't give you the precision of a scenario test, but it is the sort of thing that could help you identify issues with your boundaries around integer overflows or floating point precision or things like that. And in a system where that matters, it's useful to know that stuff. And sometimes you don't know if that matters or not until you're aware that it is actually a boundary of your system.
Yeah, I like you bringing up the boundary things, and I do agree that you can generate for addition. You could generate two numbers and say, okay, it's not going to matter which order I put them in. So the addition of A plus B should be equal to the addition of B plus A.
Right. Cool. Well, thank you all. Feel free to ping me in the Slack if you've got questions about this stuff. I actually want to work up a blog post on this technique at some point. And using FastCheck, I've found out that I can actually visualize what the rose tree generator is doing. It's something that I've thought was kind of interesting when I first encountered the technique. And I don't know, I think it would be fun to make a sort of exploratory piece explaining how those generators work and walking the tree and shrinking the values down.
Yeah, I would. Thanks, other Matthew. Pretty much the only. I would encourage you to do the blog post. I've been very quiet because I've been, partly my attention's divided, and partly this is a smidgen outside my being able to follow along without full attention. But thank you.
Of course.
Yeah, this is great.
So I haven't used Quickcheck for Erlang, but I have some friends who have, and they said their favorite feature about it was, so you're talking about like randomness of different processes. In one of your cases, you had different operations trying to run at the same time. And in the Erlang version of Quickcheck, one feature you can turn on is the pathological scheduler that will just do the most insane scheduling possible of all the different processes you have running concurrently and try to find bugs that way. And they had some stories that would just crack me up about like how evil it could be to your code.
Oh man, if you start searching the web for some just descriptions of this, you get some like super there's nothing intermediate level. There's some like really basic stuff, and then there's also, I think, testimonies about it. And like Volvo found bugs in some of their car software with this technique that probably like never would have come up otherwise. Maybe it's on. There are other cases as well, but you know, it's also, I think, equivalent to fuzzing as long as you can take an input and an output and make sort of generic assertions about them. Like you could probably even do this with shell programs. You don't have to necessarily test individual functions. You could call out to some other program and do it that way as well. The initial example around like that I had around the formatting to SQL time and reparsing it is one that I like because it just immediately shows that there is a property of that particular thing that I did not know about and would never have gone to look at. And maybe it doesn't matter. You know, but if I were putting something into a SQL database that needed to happen in 10,000 years, well, okay. You know, what it helps me do is understand the things I can't do that I didn't know about, and particularly when you work in finance, when you work in healthcare, you really need to know about those things because there are oftentimes real significant consequences to small bugs that nobody would have otherwise anticipated seeping through. Cool.
That was interesting. Thanks.
Yeah, of course.
Thank you. Now I'll do a magic trick.